In this lesson, we're going to talk about writing equations of lines in point-slope form. Point-slope form of a line is f of x is equal to m, which is the slope, times x minus x1. x1 is just the x value of the point that we're given, plus y1, where y1 is the y value of the point that we are given. We can write the equation of a line given a graph, given a table, or just given the information on 2 points. Given the graph, we could either use the graph to read what the slope is by counting the boxes and looking at the scale, or we can use our slope formula. If we want to use our slope formula, we're going to pick 2 points. So in this case, I picked the y-intercept and the point 3, -1, and use my slope formula. So I'm looking at the change in y divided by the change in x. It's the same as counting the boxes. If I went down 1, 2, 3, 4, and across 1, 2, 3. -4/3. Since I was given the y-intercept, I can just go in and write it as y equals mx plus b. But if I specifically wanted point slope form, I could use the other point and have y equals m times x minus 3 minus 1. If we're given the y-intercept, again, you can go in either form. But if we're not given the y-intercept, there's no reason to go and find it. Just use point-slope form. As you get higher in mathematics, you'll notice that really no one uses slope-intercept form unless you're given that y-intercept. No one goes out and finds it. You just go in to use the other form. Here I have this horizontal line. Remember, the slope of a horizontal line is 0, right? There's no change in y. And the other thing that we notice is that the y value doesn't change. No matter where I am on the line, the y value is always -1. Well, that gives me the equation of the line. Y is equal to -1. Similarly with a vertical line, if I look at this line here, the x values never change. They're always -1 here. So x is equal to -1. There's no slope for a vertical line. Numerically, we did the same thing that we did graphically. You could pick 2 points and use the slope formula in order to find what the slope is. So here I picked -3, -1, and 1, -9. Again, looking for the change in the y values divided by the change in the x values, I get a slope of -2. Since I was not given the y-intercept, I don't see it here in the table, I'm just going to use the first point and write my equation in point-slope form. You could have also used the second point. It really doesn't matter which point you use. You can use any point that's on the line. Algebraically, again, similar process. We're given the 2 specific points that we're using to find the line. We're going to first find the slope, which I did, -15/7. And then I'm just going to write what the equation of the line is. -15/7 times x plus 5 plus 7. Or you could have also used the second point, -15/7 x minus 2 minus 8. Notice how with any of these slopes, I never found what their decimal approximation is. Unless you're asked, don't do it, because when you start to approximate, you're changing the line that you're looking for. Keep everything as reduced fractions. So remember, when we're looking for the equation of a line, don't always default to that y equals mx plus b. If we're not given the y-intercept, we're not given that value 0, a number, don't waste your time trying to find it. There's a lot of error that can be made and a lot of time that's going to be wasted. Use this point-slope form because it's just more useful in the long run. You're going to go and find your slope using your slope formula, and then you're just going to put everything into this format.